Hello everyone. So today is going to be our day 24 of the DSA challenge. And the question that we're going to solve today is longest substring without repeat. And obviously now that you know what a subarray or a substring is, in a string you call it a substring, in an array you call it a subarray, right? So see if you can hover over it, a substring is a contiguous non-empty sequence of characters within a string, right? That is what a substring is. The question is a straightforward question. So given a string S, find the length of the longest substring without repeating characters, right? So if we take the example, this, yeah, if this is the example that is given to us, see, A, B, C is one substring, right? You know how to generate substrings, right? This is one substring, then this is two, three, four, and blah blah, right? Then from starting from here, this is one, then this is two, this is three, and so on, right? For every index, you will start from that index and then you will generate till the end of the string, right? You will generate all the substrings. Great. So brute force says that, hey, let's just say I will have a function that might check repeat, right? You can obviously create that function yourself now, right? Now, what will it have? We'll discuss later on. But here, you can have a function that generates maybe sub strings from given S, and you can generate by using two loops for I starting from 0 going till n. That is the n is the length of the substring. Sorry, the string, and J will start from, you know it, right? It will start from I and go till N. Great. Another. You know that you will achieve this in a very naive way from N cube. If you optimize it, you can go back to O N square. And this function, it will probably have a map or a set. Right now, what is a set? You already know that it stores the unique values. So time complexity we have already discussed. This function does not take any extra space, but this function does. And somewhere here you will call this function. So space complexity will be nothing but what do you call O of n. Also in this substring, right? When you've generated all these, from you have generated all the substring, you will you will send this to this function, and this function will take one more time complexity O of maybe m, where m is lesser than equal to n, and m is the length of the substring, basically, right? So this is the time complexity and this is a space complexity. I hope you already know, and if you don't know how to generate substrings, you can watch my Kadans algorithm video, and there you can find out, right? Great. Now let's see the optimal one. Now, optimal also, this is not the optimal one, this is better one, better slash optimal. Okay. Now, why am I calling it a better and an optimal way? Because I'll tell you something. In interviews, right? People don't usually ask you to, optimize it that further, right? See, I'm giving you a disclaimer right now. This can be solved in O of 2n, right? And if you explain the interviewer that why are you taking the O of 2n, maybe he will not force you to, go to O of n, right? O of n. But if you just stop here and not even tell that, hey, O of 2n is just O n, because we ignored the constant, then he might grill you to, tell this O of n solution, which we'll discuss later on. So we can solve this first, okay? Okay, let me paste the substring here, right? Great. So see, we have done almost three questions now, which includes subarrays or substrings, right? Basically, subarrays, two questions of subarray, and this is the third question which we are using for substrings, right? You already know that we use something sort of a map or set, right? Where we calculate if this string is present or not present or whatever, right? You already know this by heart now. So that is that is the same thing that we are going to do right now. Let's take a set, okay? Let's take a set and let's first try it, okay? Let's see the intuition first, okay? By the way, the answer for this question, what do you think should be? The answer should be obviously 3, right? Because ABC is the longest string. Great. So this is the longest substring, right? Or maybe you can take this one as well or whatever. Doesn't matter. Okay. Let's take a length which stores the maximum length of the current length and the max length, right? The math.max is equals to max length and uh, basically the current length. So you already know. Cool. Let's keep a left pointer here and a right pointer here as well. Okay. Let me do one thing. Let me enlarge on it a little so that you guys can see what I'm traversing to. Yeah. Okay. Cool. See, is A present in my set right now? You will say no, it is not present. Okay. I'll do one thing. I'll add A here. I will remove my right pointer here and move it a little bit. Now what will I do? My length would be my temp length would be this something which will be r minus l plus 1 and my max length will be maximum of temp length and max length. Great. So this is what now where is r? R is at 1 1 minus 0 plus 1, so that will be um okay. So basically, I will not move my pointer first. You can do anything. If you want to move your pointer first, then you can just say r minus l. And if you move your pointer after it, then you can use this. So I will not say plus one. I will say that, hey, I only have length one. Or maybe I will move my pointer later on, right? I will move my pointer later on just to keep that heterogeneous, thing. So here I will say plus one. I've added in the set, and where is L? R minus L plus one, that is 0 plus 0, 0 minus 0 plus 1, that is 1. Great. I have moved my right pointer ahead. Is B present? Is B present? No, it is not present. I will add it. Cool. And this will now become what? This was 1, and now this becomes 2. This also becomes 2. This moves ahead. Good. Is C present? No, it is not present. This becomes 3. This also becomes 3. This moves ahead. Now something happens. Okay. Now something happens. A is already present. A is already present. What I'll do is I will move my left pointer ahead, delete this, and add again this R. What is this R? This is A. So I'll add A again. I'll delete it, move the left pointer ahead, and what will be my calculation? R minus L. So R minus L plus 1 again is 3. So it will remain 3 only. Now it includes only all the unique ones. Great. Moving ahead. Okay. Oh, sorry. Just to, clear everything out so that now my R is somewhere here. B is already present. What you know? So I will move my L here. B is added again. What is this now? This is again 3. Then again, max length is 3. Great. Mm, where is my R? Okay, here is my R. R again. Now what is this? C is already there. Delete C, move L pointer ahead, add C. Okay, great. Again, it will remain 3 only. This max length also remains 3. B is already there. Remove B. Okay, move L pointer ahead. R pointer stays here. B is added. Now what is R again? R is again B. Okay. So you will notice that L is again a B. L is again a B. Delete it. Move your L ahead. And R is again added. B. Right. C and B. Now what does the length become? It becomes 2. Will we update my max length? No, I will not. No, I will not. I will move my right pointer ahead. It again includes this. L comes here. B is added. R and B again. B is again added by deleting it. L comes here. Max length, this length becomes 1 and max length remains 3 only, right? So this is L and this is R, and when R moves ahead, going out of the bound. So we don't need that. Great. Now, why did I say that a taking it is taking a 2n of time, right? I told you, right? Okay. Let me write something. Let's just say I have A, B, C, D, E, F, Z, Z, right? My L let me do something. Let me take another. My L is here, R is here, right? And this includes a set. So R when comes here, right? R when comes here, these are all unique. These will be added in this. These will be added in this, right? And then my R comes when here, right? And okay, now it doesn't have anything. It doesn't have anything. But when it comes here, then a problem occurs. Now that the problem occurs, L comes here. Okay. So you already know that right has surpassed all these things once at least. So O of N. Now L goes from this to this. That is one. Then L comes here. Then L will come here, here, now here. And again, it includes then also here. So you know, right? You know that every element was traversed two times. So O, hence to O of 2n is the time complexity. And space complexity, you already know it's O of n only because you're taking a set. Great. Now what you can do is great. Okay. What if, what if, mm, let me do one thing. I will tell you something from this example only. Great. My L is here, my R is here. Instead of set, I will take a map which stores character and index, IDX for now, right? I will do one thing. I will remove this. Cool. A at 0 and dot 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 0, 1, 2, 3, 4, 5, 6. Z at 6, right? Great. And my R is now somewhere here. When my R moves forward, it sees that, hey, Z already exists. Z already exists. Okay. Now what can I do? I can either L plus plus L plus 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 dot dot dot. I can do till here. Again, that will be 2n. But what if now that I already have its index and I know that, hey, L is lesser than my 6. I know that L is at 0 index and Z is present at 6 index. So that means I know that L is lesser than it. Okay. L is lesser than it. What if I directly bring my L to this position? What if I directly put to this position? So wherever I found this is at sixth position. What if I put it to maybe R L plus, or maybe sorry, um, index plus one, index plus one? Because see, you already know, right? You know this by because even if I bring L here, L plus 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 dot dot dot, when I will bring my L here, then only this thing will be sorted out. And let me now erase this and let me now update its value because I know 7, it is present at 7 point index as well. This is what I'm talking about. And now you will notice that every element or every character was traversed only once. Let's take some other example. Okay, let's take this example. This is a good one, right? This is a good one. Okay, let me take some other pen. maybe, you know, okay, this. So L is here, R is here. This is a map, okay. B is present at 0. Great. R moves ahead. Oh, it sees something. It sees something. Now my length, it was nothing but R minus L plus 1. That was 1 again. And max length also. Max length also becomes 1. Cool. L B is already present at 0. That means I need to bring it to what? 1, right? Index plus 1. I will directly move my L to this position. Do you remember? Do you see that I only traverse this B only once? Great. I move ahead, and this was updated as 1. Great. Move ahead. Oh, again I see it. I will move this to 1. Max length again is 1 only. It will always remain 1. So I don't think I need to update this every time. Great. L has been here. So this moves to 2. R moves here. Again, L has to be somewhere here again because L was present at this position now. This becomes B comma 3, right? R moves ahead and you will notice at 3 positions, again, L will come here. Okay, this becomes it. And max length always stays what? Let's take some other example as well. This one example. Great. L here, R here. P at 0. Okay. Length, max length. L becomes 1. Max length also becomes 1. Cool. R moves ahead. W at 1. Cool. R moves ahead. Oh, W is again present. It is present at 1. So where will I bring my L? Where will I bring my L? I will bring my L to this position. This becomes 2 and L minus R is plus 1 is 0 only. Also, till here, it would be updated to 2, right? And this again updates to 1. So max length now becomes 2 till here, right? Till here. Great. Now R moves ahead. Max length becomes 2. Sorry, this was already 2. K is not present. K is not present. What is my K? K is nothing but 3. Great. Moves ahead. This becomes 3. Cool. Uh, so E is present at 4. R moves ahead. Oh, oh, I see that now L becomes 4, right? L becomes 4, but it does not become 4. Why? Because W is already present there. W is already present. It remains 3 only, and which is at 3, 2 position. It is at 2 position, right? So L 0, 1, 2, and here will I bring my L. And what is my R now? It becomes 0, 1, 2, 3, 4. Oh, 0, 1, 2, 3, 4, 5. Sorry. This becomes 5. This becomes 5, right? And this is now my substring, which I am going to assume as my maximum, although I've already received it from this position as well, so I will not update my max length. Is this 3 the answer? Yes, it is. Yes, it is. Let's try to code it up now, right? Let's try to code it up now because I've already discussed the time complexity, which is nothing but O of n single time, and space complexity already you know it. We are taking a extra exam, we are taking an extra space of this map, right? Great. So let my map is nothing but new map. Great. Let R is equal to maybe L is start will start from 0. Cool. let max length is nothing but also 0. Great. For let r is equal to 0, r goes till s dot length r plus plus. So that means every time I will update it. Okay, cool. Now if map dot has, if it has the element, if it has that element, okay, if it has my s dot char at r, if it has that element, now what will I do if it has that element? L is nothing but math dot max of what? Left and um s, sorry, map dot get s dot char at r mm, plus 1, right? This is what it becomes. Either plus 1 to it or whatever the r is, whatever is maximum. Great. Else, else I will do something now. Else I will say that hey, if it is not present, then map dot set s dot char at r, comma r, right? Now my length is obviously nothing but uh, r minus l plus 1, and max length is nothing but math dot max of length and max length. Let's try to return it. Okay, left, not left. This is L. Oh, great. Every answer is a wrong answer. Great. Hmm. Actually, the point is, I'll tell you something, okay? This is the only thing that changed. This is the only thing that I changed. Why? Because see, I am every time initializing a length, right? And if I initialize length here, it will not update as what I want for every iteration, right? It will either, if L is not present, if R is not present, basically if it obviously it has to be present, but the point is that it will not update its value every time, right? Or I can do one thing. I don't think it should be a problem though, because okay, yeah, it is not a problem. Okay, the point is, the one more thing that I changed was I removed that else condition, because at every moment of time I need to set the r, right? I need to set the r. What if L, it is already present in the map? Does that mean that I will not set the r index in the map? No, right? I will have to set it anyways. That is why it has to be removed from this that else condition has to be removed, because it will be done and irrespective of if it is present or not present at our position, right? Let's try to submit it now. Great, accepted, right? That was the one mistake that you need to consider. Think of yourself. Think yourself only like, hey, every time I have to set that R index, right? Even if that position is present at that position, I mean, even if it is present in it, I need to update it, right? I need to either update it. What is this thing doing? This is updating it. This is updating the left part only, but what about the right part? Remember when I told you till here, when I was updating this value as well, this is what it is doing, right? Great. So, yeah, we have done that. We have done that. We have done this question. I think what we can do is write some note, use map to store the character at R, a right pointer with its index, update the left pointer if a duplicate is encountered to index plus 1. right? Let's try to save it and let's mark it as done. Finally, we are done with all the arrays thing. And now from tomorrow, we'll start what you call is linked list. Now, to give you a context about linked list, it is almost same like an array, but there is some difference that you need to consider, which I'll tell you tomorrow, right? I'll start with a very brief video about what linked lists are, and then we can move on to the question of reverse our linked list, right? Thank you so much, guys, for joining in. I'll see you tomorrow with another video called reverse our linked list. Bye bye.